Okay, well, thanks everybody for coming to our intern seminar today. My name's Betsy Boughton, and I'm the program director of agroecology at Buck Island Ranch. And today we're going to hear from our intern, Christian Horn, and he's been at the ranch doing his internship for about 8 months. And we really enjoyed having Christian at the ranch. He's extremely detail oriented, very skilled at plant ID, and very passionate about ecology and especially invertebrates. So it was just like really fun having you in the lab. While he was here, some of the notable things that stood out to him is we're learning grasses better and working in wetlands for the first time, doing greenhouse gas measurements, and becoming a soil person as well as a plant person. So that's a huge accomplishment. So Christian comes to us from University of Central Florida, and he graduated in May 2023 with his bachelor's in biology with a focus on plant sciences. And after he finished that, he worked in California as a rare plant technician. He also worked in Nevada, so did a lot of work in the dryland systems. And then he came back to Florida to do an internship here. And I think I'll just turn it over to Christian. And today he's going to talk about one of his first independent projects, Inundated with Inverts, short and long-term impacts of sod removal on soil health and soil invertebrate feeding activity. So thank you, Christian.
Everyone's here. Can we make this bigger?
What do you want bigger? The sort of notes or
Yeah. Okay, perfect. Hello, everyone. My name is Christian Horn. I'm an agroecology research intern, and today I'm going to be presenting my research I conducted at Buck Island Ranch, specifically on sod removal. I'm looking at the short and long-term impacts of sod removal on soil health and soil invertebrate feeding activity, that there are some worms in some water. I'm focusing on sod because it is cultivated throughout the United States, with Florida being the #1 producer and consumer of it. Sod cultivation pretty much is growing grass. At Buck Island Ranch, we have bahia grass pastures. Once sod is removed, it becomes a transportable vegetative cover used to replace dead turf or to cover bare ground. Sod is cultivated at Buck Island Ranch for its agricultural and economic value. It's used to export or remove nutrients, notably soil phosphorus, which can help improve water quality. It also acts as a source of supplemental revenue for ranchers and forage for cattle while it's growing. Sod removal includes many steps, but 5 important ones I'd like to highlight is that it is first grown or cultivated, then removed. Following removal, the area is tilled to prepare for seeding. Once those seeds begin to establish, the area is fertilized. Some potential effects of recent sod removal is that it may negatively impact soil health by removing organic and inorganic nutrients. It also may negatively impact invertebrate biodiversity and change community structure due to the heavy mechanical disturbance associated with the practice. It also may negatively affect soil fauna feeding activity for that same reason, reducing the system's efficiency in cycling nutrients. But do these impacts persist? I'm researching soil detrivores because they are indirectly tied to soil health. They represent 30 to 40% of decomposition of the soil's organic matter. Invertebrate biodiversity is also important to measure because species sensitive to disturbance, such as springtails, can act as indicator species, allowing us to see the impacts and levels of impact for disturbance. Essentially, soil detrivores determine how active the soil is. This brings me to my research question, which is what are the short-term and long-term impacts of sod removal on soil health and invertebrate communities and feeding activity? My hypotheses are that after removal, I expect soil nutrients to decrease in both the short term and long term after fertilizer effects wear off. I also expect for soil organic matter and root biomass to decrease in the short term with eventual recovery. On the invertebrate side, I expect for soil invertebrate biodiversity to fall in both the short and long term. I also expect for the invertebrates feeding activity to decrease sharply in the short term with eventual recovery. My study sites are at Buck Island Ranch, which is owned by Archbold here in Central Florida. The ranch has a mix of both native, semi-native, and improved pastures. Sod is only removed at these improved pastures about every 5 years or as market forces allow. It represents a very small portion of total agricultural activity that happens at the ranch. The sod we export is also lower quality because it has some weeds. It's not golf course sod, for example. To begin my experiment, I first found sod removed areas using sod records held at the ranch as well as historic satellite imagery. I clipped these areas to the same elevation and soil type, then randomly generated 6 points per treatment with a 25-meter minimum distance between them. With this initial research, I was able to define 3 separate treatment levels, with short-term removal being 4 to 5 months ago. After fertilizer had already been applied, this is referred to as recently removed. Long-term, or 7 years ago, there was also sod removed in the system. I'm referring to this part as the recovered system. And there was also a baseline or control where no sod removal happened, but in the past, tilling and fertilizing happened. Beginning with my soil health, I measured it by taking 6 subsamples at 0 to 15 centimeters at each plot. In September during the wet season, these samples were dried and then sieved. For the soil nutrients, I sent them to UF's Analytical Research Lab, where they tested for nitrogen, phosphorus, and potassium levels. I analyzed pH at Archbold, as well as organic matter and roots. pH, I used a YSI pH sensor. Organic matter, I used loss of ignition, which is essentially burning off the organic matter. I also determined root biomass by taking 3-inch soil cores that were sieved and then weighed their dry biomass. Once I gathered all my soil data, I was able to start analyzing it. I first tested for normality using a Shapiro test. If it was normally distributed, I did an ANOVA test for significance. And if it was significant, I further broke down my results using a Tukey test. If it was not normal, I used Kruskal-Wallis, and if it was significant, I further broke it down using a Dunn test. This is my first graph of the soil health results. Bioavailable soil phosphorus remained reduced in both recent and recovered systems. This is evidence for long-term removal. On the y-axis is the phosphorus level, and on the x-axis are the treatments, with recently removed in red, the recovered system in orange, and the control in green. Soil ammonium nitrogen also reduced after a 7-year recovery. You can see this as fertilizer effects, where the recently removed system has significantly higher soil ammonium than the recovered system. This was the exact same trend for potassium. Root biomass recovered over a 7-year period as expected, with significantly less than the recently removed system. Although the control and recent do not show significant differences, further investigations may prove that there are differences. This is a table of my results. For the soil phosphorus, it was reduced in both the recently removed system and the recovered system. Soil nitrogen and potassium did not recover after 7 years. pH had a marginal recovery after 7 years with significant reductions in the recently removed system. Root biomass eventually recovered after 7 years, and organic matter seemed to have been unaffected by sod removal. Going back to my hypotheses, I expected soil nutrients to decrease in both the short and long term. This was evidenced by my findings. I also expected organic matter and root biomass to decrease in the short and long term. In the short term with eventual recovery. This was only true with the root biomass. Possibly why the organic matter didn't change is that the tillage process diluted that effect by incorporating dead plant and animal material back into the soil. The second part of my project, I measured invertebrates using pitfall traps and bait lamina. And here's my prop. This is my pitfall trap. This would be filled with a preserving liquid or a killing liquid that the insect would fall into here and perish. This is baited using sardines and blue cheese, and I cannot look at them the same. This is the exclosure I used to exclude the surface insects. You can see here in the exclosure inserted, that's it partially inserted. Eventually those holes would be all the way down into the soil, preventing the adult stage of beetles, for example, from entering the trap, and instead only including the larval stage. These traps were then covered with a cap to further prevent insects from infiltrating it, and then surrounded by a cage to prevent the cows from infiltrating it. Another aspect of invertebrates that I measured was their feeding activity. I used a bait lamina test, which is a stick, that has 16 holes in it. At each hole is a small portion of food that I pushed in and allowed to dry. Once it was dried, I inserted it into the soil with the first hole at the soil surface and the last hole 8 centimeters down. I left it in the soil for a period of time and then removed and scored each of these holes. This is a long established process. The higher the score for this bait lamina, the higher consumption. You can imagine each of these holes as a burger. And if an insect ate one hole, it ate the entire burger. And if it only ate half of the hole, it only partially ate the burger. And if it didn't touch the burger, then there was no feeding. So the higher score correlates with the higher consumption rate. Further explaining the bait lamina portion of my experiment, it was conducted from August to November during the wet season to the start of the dry season. These were left in the ground for 10 to 16 days for a total of 6 different sampling periods. 3 out of the 6 plots were chosen per treatment, with 5 sticks at each plot, spaced 15 centimeters apart, representing a 1 meter transect. Score is heavily influenced by abiotic soil conditions such as temperature and depth. So I used soil probes to measure soil moisture and temperature at 15-minute intervals. And depth, the changes in depth is actually recorded by the bait lamina trap itself. For the first set of results on my invertebrate sampling, the subterranean pitfall traps generally didn't withstand environmental conditions. Especially during the beginning of my experiment, I saw heavy flooding since the water table was at the surface at that time. I saw fish crossing the street and worms synchronized swimming. The animals were also a big issue when trying to keep the integrity of these traps. Cattle would rub against it and remove the cap, and raccoons sometimes would pull out the entire trap and try and get to the bait. The final trap design, I eventually figured out how to prevent most of this attrition, but as the dry season began and I saw diminishing returns, this part of the experiment was mostly abandoned. Some anecdotal results from it though, the recovered system showed significantly different community structure compared to the recovered and controlled systems. It was dominated by lined earwigs and ants and had low biodiversity overall. The recovered and controlled systems showed similar community structures and higher biodiversity than the recently removed system. They showed more ants, crickets, beetles, and roaches, with large earthworms possibly driving the higher feeding at these 2 sites. However, these results are inconclusive due to not enough data, especially between the recovered and control systems. For the part of my experiment that did work, the bait lamina data was compiled and modeled using a generalized linear mix model to account for both fixed and random effects. The final model is down here with feeding activity as being explained by or as a function of treatment, degree days, soil temperature, depth, with some random effects being the plot and stick number to prevent pseudoreplication. Degree days is included in this model because we expect degree days is the interaction between time and temperature. It is included in this model because we expect a highly positive relationship. Pretty much as the metabolism of an insect increases, the more feeding happens. Once I was able to normalize all my data, this is the final result with the p-values at the top corresponding to normalized at post-normalization. Here are on the y-axis are average weights even per stick, with the control having the most activity, the thaw removed having the recovered system having slightly less, and the removed system having significantly less. There is a marginal difference between the removal, the control, and the recovered system showing signs of recovery after 7 years. This graph also shows that feeding activity happens mostly in the shallower depths than it does in deeper soil, especially with the rainy season. The feeding only happened on the first 8 holes as compared to the last 8 holes, nearly double the amount. Revisiting my hypotheses, I expected for soil invertebrate biodiversity to fall in both the short and long term. I did not get enough data, so this result is inconclusive. I also expected for feeding activity to decrease sharply in the short term with long-term recovery. So far, my model shows that this is true, where there's only marginal differences between the recently removed or the recovered system and the control. Broader impacts of my findings are that sod removal has a negative impact on feeding activity, but it mostly recovers after 7 years. Soil nutrients become depleted with sod removal, while root and organic matter recover or remain unaffected by it. Measuring abiotic factors was critical to understanding the treatment effect. Without that normalization of data, the treatment effect would have been extremely diluted. Liming, overall, looking at the soil health, liming the soil may increase bioavailable soil P. This is a practice that ranchers can do to increase soil phosphorus without incorporating phosphorus itself. Future studies could include biodiversity data to see if the community structure influences changes in feeding activity, such as including worms in the bait lamina data. Also seeing overall if community structure is influenced by removal would also be great to know. Continuous measuring of soil pH would have allowed me to refine the bait lamina model and to include soil parameters as well as abiotic factors. I could also further refine the study design by taking soil data before and after removal, as well as paired bait lamina plots to see the effect of tilling with and without sod removal. Why continue this? Because it allows for insights onto how ecosystems respond to disturbance, and it also informs management. Although sod removal may address legacy phosphorus, it requires strategies to mitigate short-term soil faunal impacts and long-term nutrient sustainability. My references. And thank you to everyone, especially Rosie, who's watching, for giving me this idea to research insects and sod removal together, as well as the agroecology lab for helping me with my project, especially the people I forced to fill these bait lamina strips with, help me fill them up. And shout out to the bugs, except for the fire ants. Thank you. Any questions? Yes.
So why do you think if I remember correctly, your root biomass was lower in the natural system than in the recovered system, right? Like, why do you think that is? I mean, I know they were not significant.
Yeah, it was technically not significant. I don't know the exact answer to that, but Bahia grass, those Bahia grass systems that don't have any sod removal have generally been undisturbed for it's been a very long time, years, longer than 7 years since any disturbance has happened there. So it's maybe more that as the roots went deeper into the soil, they died, and the roots for the recovered system were like more concentrated in the top.
Yeah.
But I would need to take more samples.
I was curious about the plants. Were they the pure monocultures, or did you have diversity? Like what species were there?
None of them were pure monocultures. We produced lower quality sod, so it had desmodium, smut grass, dog fennel. The recovered system had mostly bahia grass and cypress grasses. But yeah, it's not high quality sod, so it's not a monoculture. Yes.
So, nice job, by the way. I'm curious about the earthworm part of your biodiversity, because I remember when Patrick Boland was here, he was just stunned at the amount of earthworms in those soils and the number of capsule things. And no, not the castings, and I wondered if you noticed any differences between the three systems in relation to earthworms. And then I'd love to hear what you're thinking in the earthworms were not in this system in any numbers before. So what might have been more difficult?
Can you explain better what you mean not before?
Well, prior to cultivation, the
Okay.
establishment of just huge numbers of earthworms. I mean, presumably there were lots of nematodes and things in the system, but I'm just curious what you're thinking about that.
I think, well, I didn't see any earthworms in the recently removed system, likely due to the lack of a litter layer or a living biomass layer for them to be shielded from the from the environment. This is also why there may be less earthworm activity in the recovered system, because that litter layer was removed. And in the controlled system, there's a greater litter layer and greater litter layer. But I didn't get enough data to really see that. And the worms were hard to capture in the traps because they were so big, they could come in and out of the traps easily. Yeah, they're possibly what's driving the higher feeding activity. That's why including it in alongside the bait lamina data would be more impactful than just looking at raw numbers. I looked through Dr. Bolin's research, and a lot of it wasn't biodiversity. It was looking at them experimentally, not really like the diversity of it. So it's really hard to say the abundance of earthworms or potworms, which I tried to do using traps, and it's really hard during the wet season. It's probably easier during the dry season. If I were to make this, for example, deeper to where once they fall in, they can't get out. Yes.
Have two time. Tom G says, during the work, did you notice a difference in bird predation activity on exposed? Did the birds prey on insects more?
I really didn't see too many birds in my recently removed system. I didn't see after removal really a presence of any birds other than cattle egrets, which were following the cows more than the sod removal area. But my experiment is only in part of the sod removed system, so that entire pasture was removed. So I only looked at a very small portion of it.
Okay. And the second one online is from Anna. What's the coolest insect that you found in your traps?
The coolest insect, I wish I included a photo of it, I found in my traps was actually from the infiltrated system, from an infiltrated trap. There was this orange and black dung beetle that I found, and they're a pretty rare type of dung beetle. What else did I see that was cool? I like seeing all the different types of earwigs. There's not just big ones that we normally see. There's also really small ones that look like they shouldn't be earwigs, but they are. They look like they're worms or something. And yeah. Oh, and in this photo, I can actually show you. I actually got a vertebrate right here. Oh, you can't see it. Over there, next to the beetle, to the right of it is a dead frog that unfortunately went in my trap.
Thanks, that was a really interesting talk. Could you go back to some of your box and whisker thoughts?
For soil?
Yeah. I like that one in particular. So it struck me just how much variance there was in the control plot compared to the other two. Do you think that that is also potentially like a legacy effect of this, that you have tons of variation naturally occurring and then it just, that amount of variation gets hammered down?
The reason why both the recent and recovered systems have really, or a possible reason why, is that they were both tilled more recently than the control. So with that tillage process, the first 0 to 8 centimeters are turned up and distributed evenly. So yes, that is, since it's part of the sod removal process, at least at Buck Island Ranch, it is something that we can consider because, or we should consider because varying nutrient levels will probably also allow for varying biodiversity levels or plant levels versus a uniform system such as at the recently and recovered system.
Even in like 7 years later, like there's still low variation, right?
Yes,
Yeah.
yeah, the effect seems to be permanent. Or at least 7 years, not permanent.
All right, well, thank you.